Hello students, good morning. Today we discuss about the curl of a vector field. In this lecture, firstly we define the curl of vector field and then we explain its physical significance. Now firstly we see what is curl of a vector field. Curl is the rotation or whirling nature of the field at a given point. That means the direction of the curl vector gives an idea about the nature of the rotation. Under that article, we also prove the maximum line integral of a vector field at any point is a curl of the vector field. That term we explain under its physical significance. Firstly, we define the curl of vector field. For that, we are considering V is a vector point function. That vector point function is also continuously differentiable function and it is having the three component along the three vectors x, y, z, vx, vy, vz respectively. Therefore, that vector we write unit vector I vx plus j vy plus k vz and the del operator del equal to I unit vector I dab of dab x plus j dab of dab y plus k dab of dab z. Then we find curl of a vector field that is denoted by del cross V or curl of the vector V. That term we determining by using the determinant. That determinant we take 3 rows and 3 columns. Firstly, we take the unit vectors along x, y, z axis, that is I, j, k, and its component for V and del we write here. For del, dab of dab x, dab of dab y, dab of dab z, and for vector V, its component Vx, Vy, Vz. Then we solve the determinant. That determinant gives curl of vector V equal to unit vector I. We drop the first column and take the cross multiplication. Unit vector I into dabba Vz by dabba y minus dabba Vy by dabba z plus unit vector j dabba Vx by dabba z minus dabba Vz by dabba x plus unit vector k dabba Vx by dabba y minus dabba Vy by dabba x. That term gives the definition of curl of a vector field. Now, from that definition, we also say that curl of vector is always a vector quantity. If we interchange the two terms in that curl term, that is V cross del, it is not a curl of vector. Also, it is not a vector quantity, but it is an operator. Now then we see what is the physical significance of curl of the vector point function. For that, we are considering a vector field region. In that region, the lines of vector are taken straight and parallel along the x-axis. In that region, we consider a rectangular plane whose area is very small, that is A, B, C, D, and if that plane is rotated about a given axis, then we get the new position of the rectangular plane A dash, B dash, C dash and D dash. Here if the plane is rotated, that plane we consider the small element whose area is very small, that is A, B, C, D, and after rotation we get the new position A dash, B dash, C dash, D dash. If that element is rotated about an axis, then it changes its position from perpendicular to parallel to the direction of vector field. Then what is this line integral? That line integral we finding here, that also we call here line integral or path integral. Now how we find the line integral or path integral of the element, and we prove that the line integral of the element, total line integral of the element reaches its maximum value. Hence, firstly we find the line integral. That line integral we take the dot product of vector and the small element of a line. That line we take A, the boundary edge of the element. Here, if the vector point function which is directed at any point along a line, that line is the boundary edge of the element. Here we take one example, the edge A, D. This is the line. Along that line, the vector point function is perpendicular to at any point on the line AD. Therefore, here it makes angle exactly equal to 90 degree. In that situation, what is the line integral along the line? AD. That line integral is V dot dl. Now we simplify the V dot dl. V dl cos of theta. Here theta is 90 degree. Therefore, the line integral along AD is V dot dl becomes equal to 0. Hence, we prove that the line integral along the line AD or after rotation A dash D dash position same as B dash C dash and BC, the line integral along the boundary edge if the vector field is exactly perpendicular to that position becomes 0. Now how line integral changes from 0 to maximum? For maximum line integral, we consider the another line integral along A dash B dash. If the element is rotated about an axis, we get the new position A dash B dash C dash D dash. In that position, we also find what is the line integral along A dash B dash. In that case, the vector point direction of the vector point function is same as it is in both cases. Only the line changes. The plane we write here. This is the A dash, B dash. Along that line, what happens? The vector point function makes angle theta, and that theta, it goes on angle theta, it goes on decreasing, means cos theta goes on increasing. How much it decreases? It decreases up to 0. Then cos theta increases up to the maximum limit. Then what is the line integral along that case? Line integral V dot dl dl is the small element of that line. At that point, v dot dl is equal to, it goes on also increases as theta decreases. It means the line integral along the position a dash b dash, it goes on increasing and it becomes maximum v dot dl becomes maximum if theta approaches to 0, means that plane is exactly parallel to direction of vector point function. Hence, we say that if the rectangular element is rotated from perpendicular to parallel position with respect to direction of the field, then line integral also increases from 0 to maximum. It means the line integral around the complete path, which depends upon the orientation of the element, and at certain orientation the line integral of that element is maximum. Hence, we say that the total path integral or line integral of the rectangular element under the rotation about an axis becomes maximum. That explains the curl of vector field. Hence, under the physical significance, we prove that the maximum line integral of the vector field about a given region at any point per unit area represent curl of vector field.